All right, good afternoon, everyone. It's Angie here today with a little bit of after school STEM. And today we're going to talk about water. And we're going to talk about one particularly interesting feature of water. So first, we'll look at some water molecules. Get my containers out of the way. So these are some wonderful little magnetic models of individual water molecules. And water is probably one of the most famous or most well-known chemical symbols that we have. It's H, little number 2, and the letter O, so H2O. And when we say H2O, what we're talking about is 2 hydrogen molecules and 1 oxygen molecule. So in these handy-dandy little doodads, the big red part represents the oxygen molecule, and these 2 little white parts represent the hydrogen atoms. And I don't know if you notice, but I happened to do my hair inspired by water molecules. So I have my giant oxygen atom with 2 little hydrogen atoms. All right, that's lame. All right, so because of the way that this molecule is arranged, it has some really interesting properties. And the one that we're most interested in today is its polarity. So that means one side of the molecule has a certain charge and the other side of the molecule has the opposite charge. So we've got a positive end and a negative end. And just like in magnets, what that means is water molecules like to stick together. Opposites attract. So 2 hydrogens don't really want to hook together. 2 oxygens aren't really going to want to stick together. But if an oxygen side and a hydrogen side get close to each other, they're going to want to stick. And so what that means is water sticks to itself. And when water sticks to itself, obviously we have a big fancy science word for that. And that big fancy science word is cohesion. So when we say cohesion or cohering, that means something is sticking to itself. Another way something can stick is if something sticks to something else, and that is adhesion. So we have cohesion, sticking to the same thing, and we have adhesion, 2 different things sticking together. All right, so water is cohesive, and what that means is it sticks to itself, and that means it can do some pretty cool stuff. So the first thing, let's get this over here. So I have my wonderful gigantic jug of water. All right, so when the molecules stick to each other, or water sticks to itself, let's see, we can see that the little droplet sort of hangs there, and it doesn't fall right away. It waits a little while until gravity sort of catches up. Fun fact, the generally accepted volume for a single drop of water is 0.05 milliliters. And there are roughly 1.5 sextillion molecules in a single drop of water. So 1.5 sextillion molecules. Now, sextillion sounds big. I don't really know what that means. So I had to look it up. And 1 sextillion is equal to 1 billion trillions. So there are 1,000 millions in a billion, and we have a billion trillions to get to a sextillion. So there is 1.5 sextillion individual molecules in each drop of water, roughly. All right. So one really interesting thing that happens when water sticks to itself is something called capillarity. And capillarity is sort of water's ability to climb. It's kind of a bad way to describe it. But one way to see it is if we take a tube and fill it with water. Let's see if this will work. Now, if you look really close, if we get it lined up just right, we'll see that the water isn't just flat straight across. It sort of makes like an upside down, almost like a bowl shape. So the edges, the sides of the tube, the water is kind of crawled up there. And that kind of bowl shape or disc shape has a name. It's called a meniscus. And that is because the water molecules are sticking to themselves, cohesion, but the water molecules are also sticking to the side of the container, adhesion. So when cohesion and adhesion work together, we get something called a meniscus, which is basically capillarity. You maybe have even heard the word capillaries. We call the little teeny weeny blood vessels in our body, we call them capillaries. And all right, so I'm going to add a little bit of food coloring. All right, just to make it a little bit easier to see. All right, I'll shake it up a little bit, mix around. All right, so this is a very, very tiny, very thin glass tube, and this is actually just called a capillary tube. Now, all I'm going to do is dip this in here, and will it show? We can see very closely, we can see the water sort of crawling up inside a very small tube. All right, so here, this is just a piece of coffee filter, and what we're going to do is we're going to put this coffee filter in here, and the water, through capillary action, is going to slowly, not even slowly, very quickly, we can see the water sort of coming up. Fold it in half. Now if we fold it over, we're going to let gravity help us. All right, let's start with a freshie. All right, so I'm going to dip my paper down into here, and through capillary action, the water is going to be able to climb up and out. We can see it starting to go up, and as we talk, it'll probably keep going. All right, so cohesion, adhesion, sticking to itself and sticking to other stuff. So that is leading to, we've got our capillary action going on. It also leads to something called surface tension. And so what I have here is just a plain old sewing needle and just a plain old glass of water. Now, theoretically, I should be able to float. Nope, not even close. All right. So if you've ever seen a water bug standing on top of the water, it looks like there's little teeny indentations, and what's happening is that the attraction of the water molecules to each other is stronger than the force of the little insects pushing down. And so that's how certain animals, especially the small ones, can sort of float or skim across the surface. And you don't happen to have a penny or a nickel, do you? I forgot to grab my change. There's a bunch of pennies on my desk.
We'll be back with your penny.
Thank you. Technical difficulties. All right. While we're waiting, we can kind of play with this. All right. So this is just another cylinder to kind of show the effect of a meniscus. And so the larger around, less dramatic the meniscus is, but we can still see it. You see sort of that bowl or dish shape. And let's check in on our capillary paper. That is heading right up there. Excellent, thank you so much. All right, so this is a really easy way to play with and experiment with cohesion and surface tension that you can do at home. So this is just a penny. You can use any kind of coin. A dropper can be a little bit harder to come by, so you can totally just substitute a straw, any old fast food straw, and the way you do it is, you have our open ends on both sides. You dip your straw into the water, and if you cover this side, the water basically stays in there, except I have a hole in my straw. If my straw were airtight, I could just kind of let out little bits at a time. So that's kind of a workaround if you can't find a dropper, which may be a little more difficult. All right, so what we're going to do is we're going to see how many drops of water we can fit on this penny. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 12. All right, so I'm at 15, and it's probably not super obvious on the camera, but I'm guessing we've probably got a bubble, I don't know, 3 millimeters. All right, so that's 15. We do this activity a lot, and we have had kids get 30 drops, and there might be a little bit of, oh, there we go. All right, so you can fit more than you probably think on there, and what happens is, oh, wrong way. And what's happening is the surface tension or the cohesion, the water molecules are sticking together and they are fighting the force of gravity to just sort of fall away. Let's see, I'm gonna try to move the camera so we get a really nice shot. All right, so now that it's a little more horizontal, I might be able to get a better look at the bubble. There. All right, so let's see, here we can see that our water has traveled almost all the way up to the very top of this filter paper, and we didn't even have gravity helping us. It is going straight up, it's working against gravity, and it's doing that because the water is sticking to itself and it is sticking to the fibers in the paper. So that's a combination of cohesion and adhesion. All right, just a quick little chat about one of the many interesting and weird properties of water. Thanks.